Today we will discuss a question: what happens if you design a sunken slab as four-sided discontinuous? Again, this is a question posted in Civil Era Learning community by a student, and the question is a sunken slab always a four-edge discontinuous, a standalone slab? Let's have our discussion around this particular situation and the question. As we know, generally a sunken slab is needed in a toilet when you need a space for the services and things like that, and you have a level difference between the adjacent slab and the toilet floor. A level difference can happen due to other reasons as well, but this is one of the regular common reason that you find. I have a section here, and if I draw a plan of this, it would look something like you have a room, and say nearby you have a toilet which is sunken. So I'm going to draw something like this, and let us assume that this is your sunken slab, a toilet slab, and this is your room which is at a different level. So you can see here this is at a higher level and the toilet floor is at a lower level. So here the question is, what edge condition do you take? For simplicity, let me take that this is a one-way slab and you are going to design this as a one-way slab. The dimensions are in a manner that Ly by Lx is more than 2, and it is a one-way slab, and we are doing it as a one-way slab manually as per the code provisions. I'm doing this for simplicity of explanation. So now if you treat this as a completely discontinuous slab, what happens is this is a simply supported condition and you will end up with a moment of WL square by 8. Since it's a one-way slab, it is going to span in one direction and your moment is simple WL square by 8. The question is it okay to design like this? So here in reality what happens is this slab, even though is one way and is discontinuous, the top reinforcement is not going to be true, so it's discontinuous. In that aspect you are going to have something like this, and your slab is at the lower level, and probably you will have a beam on the edges. So here this will be a beam and this will also be a beam. So in such a situation what happens is, even though this is discontinuous, there is going to be a slight fixity offered by the connectivity between the beam and the slab. So in reality you may end up having a slight support moment here which is more than 0, and this will result in this moment being less than WL square by 8. So in reality what happens is you are designing for a higher moment for the span, so you may end up with 8 at 150 or 200, whatever as per the design, and in reality you are not needing that much because your moment is generally less, and definitely you are going to give some minimal reinforcement at the top. And even if you stick to 3D or 300, the maximum allowable spacing for that rebar at the support, that is going to generally take care of this minor moment that is going to be developed because of the fixity offered by the beam slab connection. So in reality what happens is, even if the steel at the top which is provided is slightly lesser, it may not be a major concern because you have anyway designed the bottom reinforcement for a larger moment. So the worst case is redistribution, but then that won't occur because anyway you are going to provide a minimal top reinforcement. Hope this clarifies. A sunken slab can be designed as a discontinuous slab if you are doing it manually, and then ensure that you have minimal top reinforcement where it is supported onto the beam. That's all I wanted to discuss today. Hope you liked the video. Thank you so much. I request you to like the video and subscribe to the channel if you have not. Also forward the video in your social contacts. Thank you once more.